Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is aldehydes and ketones, nucleophilic addition and oxidation reactions. Aldehydes and ketones belong to the carbonyl family, characterized by the presence of a carbon-oxygen double bond. This carbonyl group is highly polar, making these compounds highly reactive towards nucleophiles. The key difference between aldehydes and ketones lies in their structure. Aldehydes have at least one hydrogen attached to the carbonyl carbon, whereas ketones have two alkyl or aryl groups attached. This structural difference affects their reactivity, with aldehydes generally being more reactive than ketones due to lesser steric hindrance and greater electrophilicity of the carbonyl carbon. One of the most fundamental reactions of aldehydes and ketones is nucleophilic addition. Since the carbonyl carbon is electrophilic, it readily reacts with nucleophiles. A classic example is the addition of hydrogen cyanide, forming cyanohydrins. This reaction is particularly significant in organic synthesis, as cyanohydrins can be further converted into useful compounds like amino acids and hydroxy acids. Another important nucleophilic addition reaction is the reaction with Grignard reagents. These organomagnesium compounds react with aldehydes and ketones to form alcohols upon hydrolysis, an essential method for synthesizing complex alcohols in the lab. Among nucleophilic addition reactions, one of the most studied reactions is the addition of alcohols to aldehydes and ketones. When an aldehyde reacts with one equivalent of alcohol, it forms a hemiacetal, which upon reaction with another equivalent of alcohol, gives a full acetal. Similarly, ketones undergo this reaction to form hemiketals and ketals. These derivatives are crucial in biological systems, especially in carbohydrate chemistry, where sugar molecules often exist in cyclic hemiacetal or acetal forms. Understanding this reaction helps in grasping how sugars behave in biochemical pathways. Another essential reaction of aldehydes and ketones is the nucleophilic addition of ammonia and its derivatives. When aldehydes or ketones react with ammonia derivatives like hydrazine, hydroxylamine, or semicarbazide, they form hydrazones, oximes, and semicarbazones, respectively. These reactions are not only useful for characterization and identification of carbonyl compounds but also have significant applications in the synthesis of pharmaceuticals and functional materials. Now, let's talk about the oxidation reactions of aldehydes and ketones. Oxidation reactions involve the addition of oxygen or removal of hydrogen. Aldehydes are easily oxidized to carboxylic acids in the presence of oxidizing agents such as Tollens reagent, Fehling's solution, or potassium dichromate. This property is extensively used in qualitative organic analysis to distinguish aldehydes from ketones. Since ketones lack a hydrogen atom directly attached to the carbonyl carbon, they do not undergo simple oxidation under mild conditions. However, under strong oxidative conditions, ketones can be cleaved into smaller carboxylic acids, a process known as oxidative cleavage, commonly carried out using powerful oxidants like acidic potassium permanganate or ozone. Aldehydes, due to their high reactivity, also participate in selective oxidation reactions. One such reaction is the Cannizzaro reaction, where in the presence of a strong base, two molecules of an aldehyde undergo disproportionation to yield an alcohol and a carboxylate salt. This reaction is particularly significant for non-enolizable aldehydes like formaldehyde and benzaldehyde. Understanding such reactions helps in designing industrial processes for alcohol and acid production. Grignard reagents also participate in nucleophilic addition to aldehydes and ketones. When a Grignard reagent, which is an organomagnesium compound, reacts with an aldehyde or ketone, it leads to the formation of an alcohol. The type of alcohol produced depends on the nature of the carbonyl compound. Aldehydes give secondary alcohols, while ketones yield tertiary alcohols upon reaction with Grignard reagents. Reduction reactions of aldehydes and ketones involve the addition of hydrogen to the carbonyl group, leading to the formation of alcohols. This can be achieved using reducing agents like lithium aluminum hydride or sodium borohydride. Aldehydes reduce to primary alcohols, while ketones reduce to secondary alcohols. Catalytic hydrogenation using hydrogen gas in the presence of a metal catalyst such as platinum or nickel is another method to achieve reduction. On the other hand, oxidation reactions involve the conversion of aldehydes into carboxylic acids. Due to the presence of a hydrogen atom directly attached to the carbonyl carbon, aldehydes are more readily oxidized than ketones. Strong oxidizing agents like potassium permanganate or chromic acid efficiently oxidize aldehydes to their corresponding acids. Tollens reagent and Fehling's solution are commonly used for the detection of aldehydes due to their ability to oxidize aldehydes selectively while leaving ketones unaffected. In biochemical systems, oxidation reactions of aldehydes are highly significant. One of the most important oxidation reactions in living organisms is the conversion of glucose into gluconic acid by enzymatic oxidation. Such biological oxidation reactions play a key role in metabolism and energy production. To summarize, nucleophilic addition and oxidation reactions of aldehydes and ketones are crucial in organic chemistry and biological processes. Understanding their mechanisms allows us to manipulate these compounds for synthetic and industrial applications. From forming alcohols through Grignard reactions to oxidizing aldehydes into carboxylic acids, these reactions are indispensable in both laboratory and real-world chemistry. We hope this video helped you grasp these fundamental concepts, which will be beneficial for your NEET and JEE preparation. Thank you. We hope this video has helped you gain a clearer understanding of hydrogen and its compounds, especially the fascinating role of heavy water and isotopes. If you found this video helpful, make sure to like, share, and subscribe to AskPrep for more in-depth chemistry lessons. Keep studying, stay curious, and good luck with your exams.